Hello and good morning, everyone, to our session, or good afternoon, good evening for the folks joining in from across the Atlantic. Thank you once again for taking the time out from your schedules to attend this webinar. I am Midun, and I take care of marketing for Kalkitech and AAC Systems. Kalkitech has always been an advocate of open standards and standards-based communication to facilitate interoperability in the true sense. Today's topic is on how to maximize the value of distributed energy resources (DERs) by market participation. This will approximately be a 40-minute session followed by a Q&A. A few general hygiene points before we start off. As we have a large number of participants joining this session, this will be a listen-only webinar. Of course, if you do have any doubts or queries, please feel free to type in your questions in the chat window during the talk itself. We will try to address them here at the end of the talk or come back to you individually in case we run out of time. All right, I would now like to introduce you to our presenter for today's webinar, my colleague Nobin Matthew. Nobin is in charge of Kalkitech's energy IoT solutions and drives DR integration, AMI, telemetry, and IoT solutions globally, working closely with Kalkitech's energy IoT products team, as well as the partners and the sales channel. He has over 2 decades of diverse experience in power utility automation as well as energy IoT. He has vast experience in various communication technologies used in smart grid and is a member of various standardization committees across the US, Americas, Europe, as well as Australia. He is in fact leading a team of experts who is representing Kalkitech in technical committees, including IEEE 2034.5, IEEE 1547, and UL 3141. All right. So without any further ado, over to you, Nobin.
Thank you, Mithun. I hope my presentation is visible.
Yes.
So thank you all for joining in for today's webinar. I will cover our production solutions primarily for DER integration and also look at how we can enable market and grid support services using our platform. So just a brief background about Kalkitech. So we are in the OT integration business for more than 25 years. We enable various data integration solutions to enable mission critical applications for edge to enterprise integration. And over the years, we have acquired more than 1,000 plus customers globally. We are present in 70 plus countries, and we have system integrator and channel partners across the globe. And we are around 250 plus engineers. Primarily, we are a technology company involved in product development and integration services. And we are a big believer of communication standards. Right from our inception, we have been active in standardization committees, and especially when we talk about distributed energy resources and the integration of devices to enterprise applications. Primarily, the active technical committees are from IEEE. If you look at it, it's 2030.5. We are also involved in SunSpec Alliance. DNP3, we have been one of the key contributors in most of the standards and ongoing work, such as WeakPack Alliance for virtual protection. We also are significantly contributing in alliances such as E4S, and also we participate in IEC technical committees involved in communication and automation. So just to give you a background of today's topic, so primarily across the globe, we are seeing the drivers such as climate change and emission targets, which most countries have set for themselves, translating to energy transition regulations. So as we see these regulations coming up, we are also seeing that there are various types of incentives and value stacking opportunities that are presented across the globe by regulators and government bodies to incentivize the adoption or migration of this energy transition. So if you look at, I'm presenting here a typical use case that we refer while discussing this point. One of the classic example is from South Australia or Australia in general, where if you look at it, they have the maximum per capita renewable or PV penetration already. So if you look at the AMO quarterly energy dynamics report for Q1 2024, we can see that gradually their renewable penetration has been going up over the past, say, 10 years, if you look at it, and it has almost reached 70 plus percent of renewable energy penetration. So bulk of it is coming from solar, which is grid solar, as well as distributed PV solar, then wind. So and if you look at most geographies, most economies, I mean, we will see a similar trend. If you look at the European or Californian market, if you look at the DER penetration, we are seeing a trend, something like this, what they have in Australia as well. So in Australia, if you look at it, the increase of solar, PV grid, battery storage, and coordinated CER is expected to go up significantly as most economies transition to a green or zero emission targets. So what this means to the DER industry is that there is an increased need for DER orchestration, integration to enable grid support services because of the variability of all these assets coming on. You actually need to have a lot of support for the grid by orchestrating the DER. And then there is always a market. If we look at most markets, including the European Union, as well as in Australia, I mean, there are negative prices, primarily driven by higher penetration of these renewables, which are intermittent. So it builds up a story for adding more storage and also grid support services that these DERs can be enabled with. So with that background, I will move on to the DER integration and the opportunities ahead of us. So primarily, I mean, if you look at it, there are two types of DER services that can be used to monetize these assets. So from a value stacking perspective, the first one is obviously the market participation for renewable energy arbitrage, wholesale and retail arbitrage. So if you have storage or hybrid assets, you could then basically look at wholesale or retail market prices and then dispatch your asset to have a portion of your returns coming in from the market services. You could, if you are a commercial or industrial type of DER site, there is value to be gained from time of use management. So most of the billing happens primarily based on time of use tariff for such customers. There are demand charges, so which you could use your DER assets to optimize. And then there could be self-consumption that you can enable. And there are also other non-tangible benefits of DER, such as, I mean, as backup or additional, I mean, offsetting green or carbon footprint and so on. So in addition, the frequency control ancillary services are also another key driver for deriving value for the DER assets. And on the grid support services, as the penetration goes up, utilities are required to, or market operators are required to enable flexibility services, primarily to relieve network congestion, improve hosting capacity, investment deferrals, and so on. And from a grid stability or reliability perspective, I mean, we are looking at contingency reserves, ramping reserves, and from a power quality perspective, frequency regulation and voltage support is also a key area where DERs can be orchestrated to contribute. So from to enable all this, Kalkitech has these product offerings. Primarily, the first product that we have is our DER aggregator. So this is a cloud-based service that we offer using our Kalki.io data hub. So we enable multiple different types of DER assets to be integrated to the aggregator, and then help integrate those assets with market as well as grid support services. And for the utilities to enable grid support services, and as part of their LB DEMS or DEMS applications, we provide our data hub as a utility server, which enables DER assets or aggregators to come and connect to their backend applications. We also have an edge, which basically enables orchestration of multi DER sites to achieve export control, to achieve load and load management and optimization, or enabling features like self-consumption. So we have an intelligent edge that can talk to multiple different assets and then integrate with market and grid support services to extract value for the assets that it integrates. And on top of this, we have certain tools for enabling the integration and testing, onboarding, as well as certification for OEMs, as well as system integrators who are looking to integrate their systems with utility systems for compliance purposes and so on. So with this, I will go directly into our DER aggregator. So the primary objective is to orchestrate DER assets for enabling market applications such as virtual power plants and grid support. So this is an architecture diagram explaining the Kalki.io data hub. So this, as I mentioned, is a cloud-based service. We are hosted in the US as well as in Australia and India. We can primarily support hosting in multiple geographies based on the requirements of aggregators. So primarily, this is used to integrate devices directly from DER sites. Devices or sites that are enabled with IoT communication can be directly integrated with the data hub. We also provide options to integrate with OEM cloud applications, where they have fleet-wide portals for monitoring or bringing in data from their devices. We can also provide our gateways, edge gateways, for integrating devices that require orchestration at the edge. And all those integration is done on the southbound interface using various connectors and device adapters. And once the data comes in, we primarily can integrate with multiple utility applications for grid support as well as market participants. So this is a detailed diagram of the blocks involved. So we have a bunch of protocol connectors that brings in data from field devices. on standard protocols like IEEE 2030.5, DNP3, OCPP 1.6, OCPP 2.01, OpenIDEA. So any device that talk on these protocols can be readily integrated to our aggregator platform. And we also have provision for a DER Connect API, which can be used to integrate OEM fleet. So we can also do custom connectors with any fleet provider using our custom connector framework. And then once the data is ingested into the platform, we have applications to manage the monitoring, commissioning, and troubleshooting of the device integration. Device provisioning and configuration is also we support in-band registration and provisioning. We provide elaborate functionalities to enable automating most of the workflows around device provisioning. And we also provide a validation tool using which OEMs or fleet owners can come in and then integrate and validate the integration of the data into the platform. So once the data comes in, we also provide aggregation and disaggregation functionality, so we can basically aggregate the data based on dynamic grouping or based on network topology or any preferential any grouping that is preferred by the application, especially if you look at VPPs or other market functions. There are different types of grouping based on how the DERs need to be stacked up to derive value from a particular market or grid support function. And we have a DER data schema which enables uniform data integration with multiple different platforms. So the applications that fetch this data from our platform need not have to know the intricacies of each and every different protocol. So we can do that orchestration in terms of transforming the data into a standard DER device data schematic. So we can act like a DER data exchange that can bring in data from different assets and then orchestrate them and then provide it into various market applications like a VPP or a dispatch optimization or some kind of a market application that basically can then look at pricing signals or look at forecast and do bidding strategies to enable optimization of the assets that are grouped. And at the same time, we also provide standard-based connectors to utility applications such as LV, DERMS, or other DR programs using standard protocols. So this provides a lot of flexibility in terms of how each of these interfaces are exposed. So we support both asynchronous and synchronous mechanisms for exchanging data with various applications, as well as receive commands from those applications to dispatch the assets. And on the southbound interface side, we have already onboarded a lot of different types of inverters, IEDs, controllers, and submeters. So from a integration perspective, we have a large set of devices that we have already integrated. And some of the integration is also facilitated by a large set of protocol libraries that we support within our Kalki.io Data Hub platform as well as at the edge. So especially in North America, we look at IEEE 1547 standards for DER integration. A lot of these OEMs of DER assets now support Sunspec standard or IEEE 2030.5 or DNP3. So we could readily interoperate with all these devices that support 1547. In addition, we have standard Modbus, MQTT, OCPP, and so on to integrate DER devices. Apart from that, we have other protocols. So if you are in a commercial and industrial kind of DER site, you might need to integrate with EMS systems or other systems using OPC or DLMS or Modbus or BACnet kind of protocols. We also support those type of integration as well. So now coming to the utility server, which basically is an offering for enabling grid support services that is targeted at utilities who are wanting to orchestrate DER devices at scale. So this is an architecture or a diagram representing the utility server. So the main component of our utility server is a IEEE 2030.5 server functionality. So this basically enables OEM fleet aggregators, DER aggregator gateways, or DER clients that talk 2030.5 protocol to get connected to a utilities cloud account or their system. And then once the data comes in, we can uh, connect this data to various connectors, um, which can be for applications that are deployed in the cloud, such as cloud native applications using, say, Azure Event Hub or Kinesis. Or it could be a custom utility application that can be integrated using REST APIs or a data streaming on connectors such as Kafka. So, and then we can also collate this data and aggregate the data into an IEEE 2030.5 client interface, which can be integrated with DAMs and ADMS applications as well. So moving on, for the grid support services, we support the device grouping and the provisioning and enable various different protocols for integration with utilities backend applications. So the utility connector suite also provides all these different protocols and interface options once the data comes into our platform to integrate. So from an orchestration perspective, as I mentioned, we can bring in data from different protocols and different interfaces such as OpenADR or OCPP 2030 or 61850 or MQTT. So each of these protocols provide, some of them come with information models, some of them allows custom information models to be defined. So one of the challenge while orchestrating such different diverse set of assets is to do the data transformation, and then what we provide is a canonical data store, which can basically represent the data in a standard format, and then we can have the data transformation as required from each of these protocols into this canonical model, and then we can also enable content-based routing. So you can point a subset of this data to be reported to, say, a DEMS application, another set to a historian application, another to Azure cloud optimization or analytic application, or if there are VPP applications or optimization applications that you readily use, we can transform the data and then provide that into those set of endpoints. So we provide a very versatile platform for orchestrating the DER data. And with our experience working on different geographies in North America, Europe, as well as in Australia, Asia Pac region, we have made really good progress in terms of how we use this canonical data store to achieve the DER orchestration. So from a connector framework perspective, we have a bunch of ready-to-use connectors. So all these Exchange connectors that you see here are ready to use. We have multiple customers using these connectors, already very mature integration options, which can be readily configured to point to your endpoint. So once the data comes into our platform, taking it out onto any of these interfaces is pretty straightforward. We also have internal connectors which can be used in between these connectors. So, for example, if you, as I mentioned earlier, we have content-based routing. So you can say that telemetry data goes to a particular endpoint. The command responses can be routed to another endpoint. So if you look at the command response, you will see that there is a different content format in those messages, and then based on that, you can implement those content-based routing. We can also do data transformation, including conversion to standards such as SIM. We also have collator as well as splitter connector, so you can slice and dice the data based on how you want to take it. So there could be a lot of instances where some of your applications may not need the whole set of telemetry data coming in. So we can split it, or we can collect similar data types coming from multiple assets and then send it out as a common data JSON uh, format. So moving on, we have on at the edge, we have our DER edge gateways. Um, we offer three options here. Primarily, our offering is a edge gateway hardware that basically is rugged and certified for use in North America, as well as we have customers using it in Australia as well as in Europe. So these are proven edge gateway platforms. Uh, in addition, we have an embedded module for OEMs who want to integrate the gateway functionality as part of their inverters or site controllers. So this OEM or embedded modules can be plugged into their devices and enable 1547 interfaces. We also have an edge software stack that can be deployed on containers in edge hardware, such as inverters or battery controllers or energy management controllers at site. So this would be helpful for, again, OEMs to get their systems ready for integration to utility systems or market applications. So this is one typical architecture for a commercial and industrial grade battery storage site. So as we see that there is a lot of new battery projects coming up in most of these geographies where we are seeing negative pricing or markets where you can do energy arbitrage and frequency support. We can use our Calculator edge-based sync DER gateways. These gateways are pretty powerful in terms of orchestrating these assets. You can implement control logic. You can do data storing. You can do uh, various interlocking and other functions to enable things like export control or load limiting or to manage self-consumption and so on. So all these functionalities can be made available on this. We are also in the process of implementing the power control functions required as per the UL 3141 requirements in North American market. So the utilities could schedule constraints for a calendar year, and then we can basically use the DR gateways to enable power control functions to manage load as well as DER generation and battery assets to achieve the constraints scheduled by the utilities or grid support service providers. So once the DER orchestration at the edge is done, they get integrated to our Kalki.io data hub. So the data hub, as I mentioned, we have hosting in Australia or in the US, or we have in India as well. So we could integrate it with one of those SaaS options, and then integrate to the uh, retailer platforms or the applications provided by the DSOs. So depending upon the regulatory requirements, like for example in California, they have a regulation for all 1 megawatt and above assets to be connected to the utilities backend system using IEEE 2030.5 protocol. So we provide the integration from our Calc.io data hub. We are already a approved data aggregator in California. We are also an approved gateway provider, so we can enable integration of the DER assets to such utility platforms using the data hub as well as the edge gateways. At the same time, we can enable integration with the retailers or market applications wherever applicable. So now just going into the details of our edge software layer, as I mentioned, we have multiple different protocols that we enable to connect to various devices in the field. We have multiple northbound interfaces to connect to different systems. And then what we enable is edge analytics and additional implementation of applications at the edge. So we have recently partnered with a AI provider to enable anomaly detection. So if you are doing the data collection of your DER assets, the anomaly detection can basically look at any anomaly in asset performance or asset health parameters to bring out early warnings for you to take control actions. So such similar edge applications can be enabled with our platform. And on the edge, we have a very rugged hardware platform, which basically comes with a hardened OS, and we have TPM and secure boot. As we talk about this, DER security is one of the key aspects, primarily because there are large number of such DER sites, and they get kind of integrated to the applications, both at the utilities as well as to the market. So the security of this DER integration hardware assets are extremely critical, especially for larger value or large size commercial and industrial grade assets. So we provide the full security suite for enabling secure data communication using internet over the internet. So that's one advantage and a differentiation for our product. So just to summarize the edge features, we primarily do data collection, data processing, security, device management. We enable a lot of flexibility with our data hub, as well as we enable scalability. So we can connect a large number of edge devices onto our Kalki.io data hub, and then scale your system. And we also support a lot of different types of edge hardware. We can deploy on any standard hardware options. We offer 3 different packages, one for a Docker, another RPM, and the packages are available for deployment on Intel x86 or ARM or PowerPC-based platforms. So we have already pre-integrated with multiple different hardware options. So now moving on to the testing tools that we provide. Primarily for IEEE 2030.5, DNP3, and IEC 104, we provide our AAC test tools. This enables you to verify the integration interfaces. We can also provide scale testing options for testing your DER orchestration. So we are working with the utilities in the US as well as in Australia to enable various DER data simulation to provide end-to-end simulation of data and integration testing. So we have both the 2030.5 client as well as the server for our test tool. So if you are looking for 2030.5 based integration, these tools will be handy to basically validate your assumptions and integration options. So that is in a nutshell what we offer from Calcitech for the ER orchestration. So we can take your questions.
Thanks, Morgan. I think we have a couple of questions from the audience. So one question was regarding the deployment. So you did mention that it's you have a cloud deployment for the Kalki.io, but the question was like, do you support also the on-premise deployment and also like the deployment architecture for that?
Yeah, so we do support on-premise deployments. Primarily, our Kalki.io data hub is agnostic of the infra. So we can deploy in your cloud tenancy. We have deployed our Kalki.io data hub in Azure as well as in AWS. Our SaaS offerings are on AWS. But then we can deploy this on-premise as well. So if there are utility customers or large fleet owners who would want to use our data hub on their infra, we can provide that option.
All right. There was one question with regards to the deployment time. So, how much time is required, was needed for the deployment of the solution? What would be the
Yeah,
typical, and although I guess it varies, but maybe a generic average time
yeah.
would be.
Yeah, so I think from our SaaS perspective, the data hub is readily available. So you can, the steps for onboarding a typical customer is to create an account for the company in our SaaS offering. And then primarily onboarding the devices or device types that you would want to integrate into the system. So as I mentioned, we have standard integration with different OEM platforms and devices. And then we also provide testing tools and validation options to certify the interfaces. So typically, our the time frame for integration and rolling out the overall solution would be around 3 to 4 months. There are customers with smaller systems which can who can onboard their devices in like 3 to 6 weeks as well. So the uh, SaaS service is readily available. The time that would be required is primarily for orchestrating and integrating with your backend applications.
Got it. I think, yes, these are the main questions that we had received. Um,
Sure. Yeah, if you have any more questions, do send it out to us on email. So I, uh, you can either email it to sales@kalkitech.com or nobin.matthew@kalkitech.com. We'll be happy to respond to your queries.
Great. Yeah. Hey, thanks for that, Mukund. And as always, we will be sharing you this recording of the webinar probably around a day or two after the session. So it'll be coming to you as an email. And if you have, as I said, any questions or queries, please feel free to drop in a mail. Happy to address them. All right. Thank you so much once again, Nobin, and thanks all the attendees to come in on this session. Looking forward to more in the future. And
Thank you.
thank you all, and have a good day.
Yeah, thank you, Mithun, and thank you everyone for joining in. Appreciate it. Thank you.